we can extend the concept of calculating the area of a region bounded by a curve from rectangular coordinates to polar coordinates. Now suppose we have a polar curve where r is a function of theta, and if we define theta as the angle between the horizontal axes and our polar axes, and delta theta as the angle between these two lines that are very close. And therefore r multiplied by d theta gives us the arc length, delta s, or the length of the base of that triangle. And then 1/2 multiplied by the base by the height of that triangle, which is effectively an approximation to the area of that triangle. And therefore in the limit, as delta theta approaches 0, then the infinitesimal area of that triangle will be 1/2 by r squared d theta. And now we can integrate both sides of this equation. So on the left hand side, we get the area of the region bounded by the polar curve between some angle theta a to some angle theta b. And we can take the 1/2 outside the integral because it's a constant. And this gives us our final equation to calculate the area bounded by a polar curve between two angles. Let's calculate the area of the region bounded by this cardioid. Let's write out the area integral. So for this cardioid, we're integrating from theta equals 0 all the way around to theta equals 2 pi. And our radial function is 2 plus 2 cosine theta. And now we can expand and simplify this. And now you can use your double angle trig identity to simplify this term and evaluate the integral. And that's going to give you the area bounded by this cardioid. And post your answer in the comments.